Hello everyone. Today we are going to read supply system and important points regarding to this one, which is very important for any competitive exam, SSC, JEE, CAT, and IS, etc. After completion of basic concept, we will switch over to problem thing. So first complete that concepts. First one is we will read about basic structure. Electrical energy generated in generating station by synchronous generator. See, this one is very important. We have to remember the point synchronous generator. In exam, it may be asked by how the energy will be generated by which machine. Option may be synchronous machine or induction machine, or so many other options will be there. So we have to find out and we have to write there synchronous machine, because machine stands for motor or generator anything, but generator it stands for generating electrical energy. So when it comes for generation, it is generator. See, we can GENERATOR, generator, and that spelling GENERATIO and generation. So it easily you can remember generator and generation. The generating voltages are generally 11 kilovolt and 33 kilovolt. The voltage is then stepped up. See, at first synchronous generator will be there. After that, it will be step up by a transformer up to how much it will be generated. It will be step up by 132 kilovolt to 20 or 400 kilovolt regarding the distance, because if voltage will be high, our loss will be less. P equal to VI. If voltage will be high, current will be less. So current means 0.0001 in high voltage, so that losses will be negligible. That's why we are converting into high voltage. Okay, for transmission over long distance, again the high voltage are brought down to transmission level, that is 66 kilovolt. See, again this transformer, actually this one is very high voltage, 400, 220, 132 kilovolt. Again, suddenly if we will step down that one, it may have any problem may not happen, but the cost of the transformer will be increases. That's why we are converting it to 66 kilovolt for a safer, because economic purpose. So next station is step down. Sub transmission is level is 66 kilovolt. After that, to supply large consumer and further step down for a primary distribution. Primary distribution is 33 kilovolt and 11 kilovolt. Some primary distribution are required. Some electric center or substations will be there. That one is primary distribution. After that, for secondary distribution level, the voltage is brought down to 400 volt for 3 phase and 230 volt for 1 phase for residential and commercial use. See, residential means our homes and everything, and commercial use means what I can say, some small factories. There it will require 3 phase. See, one example in our college, when we are going to college, that every home is connected to one phase, and that machines and everything, machine lab or maybe power electronics lab or instrumentation, like that is connected to 3 phase. So in some colleges there is separate room for machines or that labs and separate room for study. So here we will directly find out 3 phase is given. 3 phase is for a 4 volt 400 volt, and 1 phase is 200 volt, because approximately 210 or 200, it is tell that 230 volt, but plus or minus 10% will be there. That's why it is telling 200 or 210 volt, like that. In India it's 210 volt, like that. But countries like USA or some other countries, they are maintaining 110 volt, because they are having frequency 60 hertz. But in India it's 50 hertz. This is main important point. Here another thing I want to show that, see, step down transformer, this synchronous generator, only one step of transformer is there. In whole supply system, only one step of transformer is there. Beside these, all are step down transformer. This is very very important, and here we have to remember that voltages in transmission level, primary transmission level, it is 132 kilovolt, 220 kilovolt, 400 kilovolt. You have to opt out that options, okay. And sub transmission 66 kilovolt, it is not so much important. But in primary distribution, what will be the voltage? It will give right 66, 33 or 400 like that. Then you can easily opt 33 kilovolt. And secondary distribution or load side, sometime it will ask in load side what will be the voltage. You can write if it is will written 3 phase, you will write 400, and it will given 1 phase, you will write 210 volt. Okay, to listen, it is 230 volt, but plus or minus 10% or 5% is okay. When we will read about voltage regulation, we will read about that thing. Okay, now you remember it is 230 volt for 1 phase and 400 volt for 3 phase, and in India frequency is 50 hertz. It is constant everywhere, but in USA like countries, that frequency is 60 hertz. That's why it is that voltages are 110 volt like that. If frequency will be high, loss will be less. Okay, understood? So what you will tell, one question should be in mind, why we are not converting our whole system to 60 hertz system? Because our old systems are because we are a colony of Britishers, so they are giving us 50 hertz. After that we are going on that way. If we will change now to 60 hertz, there is a huge economic imbalance will be there. We have to change everything, and every system's insulation and everything. That's the problem. That's why we are opted 50 hertz. Okay, then here some important point are there. We have to write down. Generating stations are interconnected by the line. See, generating stations means, what do you mean by generating stations? Means maybe it will be hydro, maybe thermal, maybe nuclear, maybe renewable or non-renewable, thermal, everything. But that it stands for where it will be gonna synchronous machine or generator, that it stands for generating station, and that are connected by the lines. Lines means transmission lines. Okay, transmission lines when interconnected to each other become transmission network. When two transmission lines are interconnected, okay, interconnected by some point like that, then it will be transmission network. The combination of transmission and distribution network is known as power grid. This is very important. What do you mean by power grid? Means the combination of transmission and distribution network is known as power grid. We have to find out. Then now we will read effect of system voltage on transmission power. We have to remember in mind everything. If you can't, you can write down now. Power loss in the line is inversely proportional to system voltage and power factor both. System voltage is stand for Vs. V and subscript S is supply voltage, and power factor is cos phi. Okay, so power loss is P loss is equal to inversely proportional to means 1 divided by Vs cos phi. Okay, then power loss in the line is inversely proportional to Vs 1 by Vs cos phi. We have to write down this formula. After that, percentage of voltage drop, percentage Vr is increases, is decreases when the increase in system voltage. How? V equal to IR. Okay, so when voltage drop in the resistance decreases, then increase in the system voltage, V equal to IR. Okay, so if R is equal to decreases, then increase in system voltage will be there. weight on the conductor material for the line will decreases with the increase of supply voltage and power factor. Conductor weight means transmission lines are conductor. That weight is weight of the material of the line decreases with the increase of VS and power factor. Efficiency of transmission increases with increase in supply voltage and power factor. So efficiency equal to Vs cos phi. Higher supply voltage enhance the system stability. If higher system voltage will be there, the stability will be high because loss will be less. Okay. The problem encountered with high voltage are the insulation of the equipment, corona, radio, and television interference. Means high voltage, the problem, if high voltage will be there, what problem will be occur? This is very important. Insulation failure will be there. If high voltage will be there, sometime insulation is not properly maintained and insulation may be failure, and corona effect will be there, and radio and television interference will be there. You know that thing, otherwise you will read. What do you mean by radio interference? If two lines will be there will be some attraction or opposition between them due to, because if electricity is flowing, so that will have some magnetic effect, and by magnetic effect the two line will be interconnected, means attracted by each other. If some television line will be there will be some disturbance in that signal. Okay. The voltage level of the system is therefore governed by the amount of power to be transmitted, the length of the line. Now we will read voltage level. Low voltage are low voltage, high voltage, extra high voltage, modern high voltage, and ultra high voltage. What do you mean by low voltage? Means 230 volt is for one phase and 400 volt for three phase. High voltage stands for 11 kilovolt and 33 kilovolt. Extra high voltages are 66 kilovolt, 132 kilovolt, 220 kilovolt, and modern extra high voltage are 400 kilovolt. Ultra high voltages are 765 kilovolt and above. So we have to remember everything. The maximum time it is asking what do you mean modern extra high voltage, it stands for 400 kilovolt. After that it is comes under ultra high voltage. You have to remember this thing. And conductor used in transmission line. Now we will read what conductor is used in transmission line. First one is copper conductor. Second one is ACSR, aluminum conductor steel reinforced, is ACSR. And ACAR, aluminum conductor alloy reinforced. Triple AR, all aluminum alloy reinforced. And expanded ACSR conductor. Expanded ACSR conductor is used extra high voltage lines. Okay, here what in exam it will ask, they will ask what the full form of ACSR. You have to remember that A for aluminum, C for conductor, S for steel, and R for reinforced. Similarly, see ACAR, A for aluminum, C for conductor, A for alloy, double A means alloy, and R for reinforced. Here triple AR means all aluminum alloy reinforced. Okay. First one is aluminum conductor. Aluminum conductor will be there, but steel reinforced will be there. Okay. Second one is aluminum conductor but alloy reinforced. Triple AR is all aluminum alloy reinforced. In extended ACSR, normally used in EHV lines. This last point also important. You have to remember types of conductor. See how many types of conductor? 4 to 5 types of conductors are there. First one is solid conductor. Second one hollow conductor. Third one is standard. Fourth one is composite standard conductor. Fifth one is bundle conductor. Okay. What do you mean by solid conductor? Means whole the solid conductor will be there. So according to effect, whole the electrons are concentrated on the skin. Skin means outer surface. So it is having high skin effect. Okay. What do you mean by hollow conductor? Hollow conductor means that one is only outer surface will be there, inside nothing was there, so there is no skin effect, only current will flow. This is used in heavy current, and saving of conductor will be there, so it is hollow conductor prepared under heavy current, that is more than 1000 ampere, due to absence of skin effect, and saving of copper also will be there. And after that is standard conductor, which standard conductor means like that only, which is generally used in low voltages. Composite standard conductor, where composite standard conductor are used, it is used for less than 220 kilovolt. Composite standard conductor are used for less than 220 kilovolt, and bundle conductors are used greater than 275 kilovolt. Advantages of bundle conductor. Why bundle conductors are used? Bundle conductors self GMR, geometric mean radius, increase without change in mutual distance. GMD. What do you mean by mutual distance? That center to center distance is mutual distance. See, when I will teach you GMR and GMD, I will teach that one now. You have to remember this thing. This point is very important, that's why I'm tell you now. Voltage gradient reduced, so corona loss reduced. Your voltage gradient is less, means decreases, so corona loss will be reduced. It reduces the interference with nearby communication lines. If we are using bundle conductor means bundle of conductors, means 3, 4, 5 number of conductors. It reduces the interference nearby communication line, because they are attracted by each other and they don't bother any interference line. Okay, that's the thing. After that, inductance L. We know that inductance is L of the transmission line reduced, and capacitance of the capacitance C increases. Here it is very important. Sometimes it will give inductance and capacitance, and it will ask what do you mean by surge impedance. Impedance ZS equal to root over L by C. Surge impedance is also decreases. And power system, main important thing is power system stability is increases. So you have to remember this point, and you can write by your own language. Insulator. What do you mean by insulator? Overhead line insulator provided required insulation to the line conductor from each other and from the supporting structure electrically. Most commonly used materials are, this one is very important, porcelain and toughened glass. What insulator we are using is very important, is porcelain and toughened glasses. See, this one is power structure mentioned. This one is cross arm. For example, if this one is line conductor, so between power structure and line conductor there will be some capacitance will increases, and between these two some MC means this will be also some capacitance will be there, but what will happen, it is little bit less, very less than this power structure and this line conductors capacitance. So nearby line conductor more stress will be there, near cross arm it is less stress will be there. So stress means high current, like that. Okay, so you have to remember this thing. From between line conductor and power structure capacitance will be there, because so many long distance line will be there, so in between capacitance will be there. In short transmission line no capacitance effect will be there. It will start from medium to long line. In medium also it can be neglected, but high transmission line, short, medium and long transmission line capacitance will be there. After some distance some capacitance will be generated, and like that. And one thing, if in capacitance in parallel we can, that one is additive in nature, and in series it is acted as parallel formula, like that. If resistance in series means additive, and resistance in parallel means 1 by R1 plus 1 by R2 plus 1 by R3, like that. But it is opposite for capacitance and same as inductance. Okay. When C is capacitance between metal part of the insulator and tower structure. MC is capacitance of each insulator disc. Okay. MC is very greater than C. The stress experienced by the disc near the power conductor is more than stress experienced by the disc near the cross arm. Okay. What do you mean by the string efficiency? This one is very, very important. You have to remember string efficiency equal to voltage across the whole string divided by N. N is number of insulator disc in the string into voltage across unit adjacent to the conductor. See, I have to see that. This one is the insulator and tower structure. This one is structure, and see, these are MC, these are insulator disc. Okay. So N is the number of insulator disc in the string. Insulator disc 1, 2, 3, 4. 4. N is 4 into voltage across the unit adjacent to the line of conductor. Okay. Line of conductor means this one is line of conductor. So adjacent is this one, this MC. Okay. So what will, as the number of disc increases, string efficiency increases. That's why if number of the disc increases, the string efficiency will be decreases. So method of equalizing potential across the each disc on koriba, increase the length of cross arm. We have to increase this cross arm. This arm we have to increase. Okay. Capacitance grading or grading of unit. We have to do grading of the unit. Use of grading rings and static shielding. Types of insulator. How many types of insulator are there? Minimum 5 types of insulator are there. Pin type, multi-pin type, suspension type insulator, strain type insulator, and shackle type insulator. Pin type insulator are operated satisfactory up to 25 kilovolt, and multi-pin type insulator are operate up to 33 kilovolt. Suspension type insulator design operate 11 kilovolt. Strain type insulator mechanically very strong. It is used when direction of transmission line changes across river crossing and the dead end of the transmission line. This one is very important. They will ask where strain type insulator will be used. You have to write dead end of the transmission line and river crossing. We will use strain type insulator. And shackle type insulator are used in a low tension cable. These insulator can be operated either horizontally or vertically. If you require, I will write that formulas and I will provide that pictures also. You no need to worry. We have to find out now. We are reading basic concepts. So which point I have tell you to remember, you please remember that thing and write that some formulas. When we will practice that problem, every concept I will discuss. So don't worry, enjoy, have a nice day. This is for today. Tomorrow we will read some other things. At first we will complete the power system. After that we will read any other things. First we will try to cover that concept, and I personally find this all the things. So you have to write down please, and when write down you will get some knowledge and you will remember, and these points are, which points are important, I'm finding out that thing. Okay, thank you. If you don't want any point and you want totally books concept, you can ask me also. I will cover that complete book also. Thank you. Have a nice day. If it is helpful, you please subscribe me.